Okay. Can you check stream health?
Sorry?
Can you check stream health?
Health?
It's a stream health.
Health.
See, stream health. Yes.
Health
Yes.
or health?
Health. It's like the third tab.
Okay. Where?
Not
Excellent
analytics.
connection.
Stream.
Oh,
Yeah,
okay.
this one.
Yeah. Stream health. Yeah, it's good.
Oh, so it is streaming now.
Maybe.
Okay, now we can go onto the stream. Hold on, let me check.
It looks like, yeah, it looks like.
Yeah, we're live. We're live. Hello, everyone. We are live. Perfect. It's working. It's delayed, but it's working. Good. Okay, go back to the blackboard or PEMDAS or whatever. We're good.
Not PEMDAS, Desmos.
Desmos, yes. You see my.
Although
You
I
see how
guess
much math I
PEMDAS would
know.
also be a good. PEMDAS could also be a good name for some kind of educational software thing.
All right, yeah. Let's switch to Desmos now. Everything's working. Just make
Wait, no.
sure.
Well, actually, so let's recap what we've been talking about,
All right, yeah. Let's recap because we're
right?
just starting
Because
again.
yeah, all right.
Hello, everyone. It's me, Zake, and this is Daniel. And we thought we were live, but we weren't. Oh, sorry. I took your stats.
Yeah. So we were talking about powers, meaning exponents, and then maybe at some point we'll talk about logarithms. But for now, we're talking about like powers. Well, yeah, powers and fractional powers. So for example, x squared, square root of x cubed, cube root of x. What do these things mean?
Yes.
And how we can operate with these exponents and then various kinds of roots and things like that. So the thing that Zake was asking about was a cube root. What is a cube root? And I was
Yes.
explaining that it's the opposite of cubing something. You take the cube root. So for example, if the cube root of x is some number a, then I take that number and I cube it and I get x. So let's make this more concrete. The cube root of 8 is which number?
2, I think.
2. And that is because 2 is the number that if I cube it, meaning I take 3 of them and I
You
multiply
multiply
it,
3 times, yes.
that will be 8. And we were looking at the graph of y equals x cubed. And I was explaining that if I could flip the x and y axes, I would see the graph of y equals the cube root of x. So here, look at this. Here I solved for x. So I found what is x as a function of y, and then I just switched y and x because I want to keep
So you
the
inverted it.
y-axis as the y-axis because generally in the way that people talk about math, we have the y being a function of x. So anyway, it would look like this. Then I also showed, can you pin me? Can you pin like the
You
image?
gotta close the blackboard for it or
Right,
whatever.
close the blackboard. Okay. The whiteboard.
The
Okay.
whiteboard, yes.
I also showed the following. Is this big on your screen now?
Yes, it is. Just a little
Okay,
blurry,
good.
but good.
Okay, so this is the graph of y equals x to the third. And if let me think. Wait, how do I flip this? Wait. No. I want to flip it in such a way. Oh, I see. In this way. So right now, as x goes up, y also goes up because y equals x to the third. But if I flip it, now we're looking at sort of x as a function of y.
Yes.
Because x is kind of the y-axis and the y is the x-axis. So now as y goes up, x goes up, but much slower because x is the cube root of y now.
Correct.
So it's like flipped. Okay. And now we're at the point where we were, and I was going to show you Desmos. So let's
Or
go
as I call Pem,
here.
I'm just kidding.
Yeah, no, it's Desmos. All right. So here is y equals x. They don't let me do that. It's got to be like this. Okay, great. Y equals x to the third.
Okay.
Okay. And here is y equals x to the power 1/3. Now, that's something that we haven't quite talked about yet. The fact that the cube root is the same as taking the 1/3 power. But I'm not even sure how to do it otherwise. Actually, you know what? Here's right, there's this, but then like that's square root, and I don't even know how to. Oh, maybe here? No. No. Okay, never mind. Anyway, I'm just going to write it the way I know how to write it. So this is the cube root. Notice that this is what we call a reflection of y equals x to the third
Yes.
across the y equals x axis.
Why does it do that?
So basically, this is the red is y equals x to the third, and the blue is y equals the cube root of x.
I see.
And when we switch the x and the y axes, that is a reflection across the y equals x line. If you do this experiment, what would you call it? If you do what I did with the piece of paper, you will start understanding.
I see.
In fact, one thing that you could do is just do it with a few points first. So for example, here's the point 2, 8, right? That's on the line y equals x squared.
Ooh. Like what? So those points are the intersecting points, or what are they?
I'm just giving you a point that should be on the graph, that you know should be on the graph.
Yes.
Okay. And where is it? Did Desmos actually give me the point? Where did it oh, I have to zoom out. Right. Oh, okay, great. See that?
Yes.
Now the point 8, 2, let me label it, and I'm gonna call it, you know what, actually, we can put it that way.
Oh, I see. I didn't
For
even
the
know this. What the?
point 1, yeah.
What the? What?
Now, if we take 1, 1 or 0, 0, then that's not that interesting because it's the same on either graph. So I had to do 2, 8.
Dude, that's nuts. Like, so you're
Yeah.
it's literally the inverse.
Yeah, that's the whole
So
point.
like if you 2.8 and 8.2 and they'll appear like on the dude, that's nuts. How? Like I
So 4 and 64, right? Those are also points that should be there, right?
mm-hmm.
Because 4 cubed, 4 times 4 is 16, and then times 4 again.
What about those intersecting points? Are those like because you
Okay.
see it intersects
Obviously,
with
these numbers get really big really fast, right? You see point 2 and inverse of point 2?
yes, yes.
Okay. Meaning maybe that's not the right phrase, inverse of point 2, but like the corresponding point to point 2 on the other curve. Okay, so the points where they intersect?
It's
Yeah, tell me
one.
about that. Yeah, tell me why they intersect here. Also,
Because
maybe
like no matter how much you like multiply one by, it's still one.
right. So when I take 1 to the third power, that's 1, right?
So 1 to the 1/3 power is
Okay,
also one.
they're different things. 1 to the third power That's y equals x to the third, or 1 to the 1/3 power. That's on the line, on the curve, y equals x to the 1/3 power. But in this case, they intersect because it's 1, 1.
I
Right?
see.
Yeah. Okay. Where else do they intersect?
Just that? They don't intersect anywhere else. And
That's not
zero,
correct.
obviously, but
And 0. Okay, where else?
that's it.
That's not correct.
But why?
So these two curves, y equals x to the third and y equals x to the 1/3. Look at these two curves.
Yeah.
And where are the points where they intersect?
They intersect. Oh, right. -1 as well.
Right.
Obviously.
Okay, great. Okay.
That's it? They don't intersect anywhere else, right? I'm not
So
missing
the
any.
-1, right?
Mm-hmm.
That's the other point at which they intersect.
I see. We didn't have Desmos when I was growing up. We had to have
Right.
Desmos up here.
Honestly, I don't know how long it's been a thing for, but it could be like 10 years old or more. Um, it's not that new, but yeah. All right.
Okay, so what does it have to do with logarithms? I know what they used to do something with logarithms, but
Okay. So let's go back to writing for a little bit. Let's stop sharing this.
have you been keeping track of chat? Hold on.
No, 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 no. Chat? No. What's happening in the chat?
No,
Probably
no,
nothing.
no one's here. Just
No
yet,
one's here? Really?
yet. So
No one at
you.
all?
But I recommend you share. I recommend you share the stream somehow.
I've shared it to a couple people that I know may be interested. I don't know.
All right.
Uh, I can share it. Let's see. It gets shared to my subscribers, right?
Yes, it does.
Okay. And it hasn't been shared to your subscribers, right? Because it has nothing to do
Yes, yes. No,
with
because I
your
haven't
YouTube account.
promoted
Right,
it.
right,
No.
right, right. But wasn't that part of the idea?
No, that was not part of the idea, but I can share it on my Discord if you want. Like,
Sure.
yeah, sure. I'm
I
doing
mean,
I'm doing
I'm
this.
not, I'm if you want to, sure, I'd appreciate that.
Okay.
Uh,
Hold on. Oh my gosh.
we have 2 views, average view duration 6 seconds. We
No,
have like either 0 or 1 viewers right now. So I guess that's a little unfortunate.
it
Uh,
happens. No problem. The more you
no,
stream, the
I
more it
understand.
happens.
I understand. It takes a long time. Yeah. Apparently, hmm. I understand.
Okay.
Yeah,
I shared it on my Discord.
cool. That's the unfortunate thing, though. Anybody coming now would be coming in the middle of this conversation.
It's
Um,
fine. It's fine.
anyway, so we've said that if I have x to a certain power, right, I can take a type of root of x, and that'll be like the inverse of that
So
function.
can you share the what's it called?
Whiteboard.
Yes, the whiteboard.
Yeah. So in general, if y equals x to the k power, then y equals the kth root of x is that inverse, or x to the 1 over k is the same thing.
So I mean they're the same thing. But y to the k and the k to the there. Let me just show you. Hold on.
Mhm.
I assume this is the inverted. This is like the how it is, and this is the inverted part, right? And they're equal,
Correct.
obviously. This is equal to the other one. But
Right,
that
right, right, right.
y to the k is the inverted. The y to the k is inverted by the k root of x. Yes.
Oops.
Okay, I got that part.
Okay. Now, let me be very careful here. Um, let's say y equals 2 to the x power.
Ooh.
That's a totally different thing. We're also, it also has to do with the concept of powers, but that is a totally different thing because x is in the exponent, not in the base. Right?
Yes.
Okay. So now, if I want to get x as a function of y, now we're talking about logs.
I see.
Let's
Logs.
let's explain what a logarithm is.
Logs.
Log base 2 of some number a, if that equals some number b, then what that means is that b is the number that 2 to that power would be a. 2 to the b would be a.
Ah. I
Log
see.
base
I
2
see.
is asking what is how many times do I need to multiply by 2 to get a?
So this would be then basically log. Let me see if I got this. To the. Oh, that would be 3.
Correct. This would be 3. And now let's write it the other way. 8
Is 2 to 3. Yeah, 2 cubed. Hold on. Here you go.
2 to the third power is 8.
Yes.
So you see how what I said here, log base 2 of a is b, means 2 to the b is a. We said the same thing here, just with more specific numbers, right?
Yes, I
And
see.
even more generally, log with a base of some number k of a, if that's the number b, then k to the b power is a.
I see.
Like log base 10. Log base 10 of 1,000 should be what?
Hold on. Would that be 1,000?
Log base 10 of 1,000 would be 1,000?
No, no, no. Hold on. 3 to the 3. No, no, no. It would be 100, right? No, no. It. No, 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 no. It would be 3, I think.
Yes, it would be 3. Now say it the other way.
It would be 10 to the power of 3.
Right, it would be 3 because 3 is the number of tens required to make 1,000.
Okay.
Right?
All right, I got it. Yes.
Okay. Now, taking a log is a way of getting rid of an exponent. For example, look at 2 to the third. Okay. Let's pretend we don't know how much that is. That's just 2 to the third. Okay. Log base 2 of 2 to the third should be what?
Also 3?
Okay, now let's explain that slowly. The number is 2 to the third, meaning we have 3 2's, right?
Yeah, it can be 8.
Okay, but it's not about that. 2 to the third, meaning we're multiplying 3 2's together.
Yes.
How many times do we need to multiply 2 to get the number that is 3 2's multiplied together? Of course, 3.
3.
Right. So the answer is 3. So it's not about the 8, right? Let's say this was 77. So this is 2 to the power 77. Let's take log base 2 of that number.
77.
That would be 77 because it's asking how many times do I need to multiply 2 in order to get the number that I get when I have 77 2's all multiplied. So of course it's 77. And let's say we had log base 2 of some other number like 61. Do you know what log base 2 of 61 is?
Ooh. No, I didn't.
Can you be more explicit?
It cannot be like exactly you cannot find the square root of that, I don't think.
You don't think it's an integer.
No, it's not.
Right, right. And it's not square root, but you don't know the power, like because 2 to the power, 2
Yes,
to some power is supposed to be 61, but you don't know which power. 2
exactly.
to the 5th power is 32. 2 to the 6th power is 64. So it's in between 5 and 6. But it
Yes.
doesn't, it's not going to be about that because I'm going to talk about how log base 2 is the opposite of 2 to some power. So 2 to this power should be what?
Log 61? No.
So I have log base 2 of 61, right? That means that is the number of 2's that I need to get 61, right?
Yes.
And it's 5.3742, whatever that number is, okay? When I take 2 and I take it to that power, that means I have that many 2's all
So
multiplied.
it's 61 still?
So this should be 61.
I see.
Okay, so 2 to the 61 power, if I take the log base 2 of that, I get 61. Or if I have log base 2 of 61, I take 2 to that power, I also have 61.
I see.
Okay, so sometimes you will have situations where you're interested in x, like always, and 2 to the x is
Interesting.
61,
I see.
let's say. And let's say I do have a calculator if I need, because I probably do need it, right? The answer is going to be between 5 and 6, because I know 2 to the 5, 2, 4, 8, 16, 32, that's 5 2's. And then the next one is 64, so it's between 5 and 6. I can take the log base 2 of both sides.
Okay.
And now, does something simplify? Does something get simplified?
Oh, let's see here. So 2x equals 61?
No.
Hold on, let me think. Does log get simplified? Or let me think.
This is a G. So the point of taking the log base 2 was that I have 2 to some power here, but I don't
Yes.
like that. And
So the
log
2's
base
get
2
so
is the
x
opposite
equals
of 2 to some
61?
power, right?
Is it x equals 61 or that can't be though?
So let's read in English what this says. Log base 2 of 2 to the x, right? So 2 to the x means I multiply a certain number of 2's, right?
Yes.
Okay. Now, log base 2 means how many 2's do I have to multiply to get this? We've done this, just not with the letter X, but with a number like
Well,
77.
yeah, it would be the letter. It would be the letter X then.
Well, the quantity X, because it's not
Quantity
just a letter.
X, yes.
So yeah, okay. Represents whatever number it is. So this thing on the left side would be
X.
simplified to just whatever X is.
Yes.
Okay. And that is log base 2 of 61. And this is something that you can put in a calculator or figure out somehow.
All
Well,
right.
mostly by using a calculator in the 21st century.
Mhm.
Yeah, there you have it. So
But then
that's how you
but then like this is like the pinnacle of math that I learned like in high school. I didn't learn much more than that for algebra.
that's
However,
okay.
and they didn't even explain to us imaginary numbers like the I.
Okay. That's a whole nother topic that's also interesting.
Like it's kind of connected to this though, like because of the
Imaginary numbers, combining imaginary numbers with powers is kind of interesting. Yeah.
well, yeah, that's what we learned about them. It's just like, for example, the square root of one minus one. I mean, that is the imaginary number.
The square root of -1? Yeah,
Yes.
that is I, sort of like the unit of imaginariness.
Yeah, I've seen like
Okay.
things
In
like
general, we've been talking about numbers on the real number line, right?
yes,
The real number line being the line which has 0 in the middle, if you can say that it has a middle, and it has no ends, and it goes from whatever number you think is the smallest number, even past that, all the way to whatever number you think is the biggest number, and even way past that. Right? All the positive and negative numbers and 0, right?
hmm
Any number you can think of. Now, what if numbers were two-dimensional?
how's it possible even?
Okay, so right now we're thinking of numbers as points on a number line. You see what I'm
Yes,
drawing on the bottom right, right? Right?
I see it. Yes,
Okay. So it's like an x-axis. It's an axis. We could draw it as the x-axis.
yes.
But if we're drawing in a two-dimensional plane, then why are we not using any of the points above the x-axis or below the x-axis? Why can't a point be like have two numbers specifying it? In fact, it can. We've been also operating
Yes,
with
yes.
points in two dimensions. Now, the way we operate with complex numbers is that they have two parts, the real and the imaginary. And the general way that we write them is some real number plus some real number, which is the quantity of i's in a way. For example, 3 plus -2i or -2i, right? So here's 3, let's say. Let's say this is where 3 is. And this is where -2 is.
I
So that
see.
point is right here.
I see. So we keep I as I always, or does it like have some quantitative value?
It's the square root of -1, which is not a quantity that we've been used to talking about.
I see. Yeah, I've seen
I is
like
the square root of -1. So this means that it's a -2 square roots of -1, right?
yes,
Okay. I squared is what?
one.
No. If I is the square root of -1,
Oh, it's -1.
it would stand to reason that I squared would be -1.
What the? Okay.
Okay, what about I cubed?
Also -1.
So I cubed and I squared is the same?
No, don't
Are the
tell me.
same?
Don't tell me it's just one. Don't tell me it's one. What the?
Wait, so I to the third means what does taking something to the third power actually mean in simple terms?
Multiplying it 3 times.
Right, there's three of them and we multiply them all. So
So yeah, it's
I times I.
-1 to the square. It's either gonna be like -1, no, +1, I mean, or it would be -1 times square root of -1. Hold on, let me
Okay,
write
so
down.
that's I times I, right?
Yes.
Okay,
So what I'm imagining is this. This is the solution.
correct. We can write the square root of -1 as I, because that's what we've been doing, right?
Yes.
So yeah, so it's I times I, which is -1. So this part is -1, and then times I. So negative I, or
I
-1 times
see.
I. Okay, what about I to the fourth?
Oh, that would be just -1. Or was it be +1 at this point? It's like, yeah, it's just one.
It's 1, +1, because that's I times I times I times I. And we can just group two of them together like this. So I
Yeah.
times I, that's -1 times -1. That's +1. Very interesting.
What about the square root of -2 or 3? Is it also imaginary numbers, but we don't mark them as I, or how does it work?
Okay, let's that's okay. Let's talk about that right now. Square root of -2, right?
Yes.
So let's say that we have some small degree of comfort with the idea of I being the square root of -1, right?
Sure.
How can I sort of phrase this in such a way that it relates somehow to I, or to the square root of -1?
2I?
So you may remember the square root of like two numbers multiplied,
Yes.
that can be written in a different way as well. The square root of AB.
Would that be.
Yeah,
No?
the square root of A times the square root of B. Correct. Because if I square the square root of AB, then I get AB. But if I square the square root of A square root B, then I get square root A times square root B times square root A times square root B, which there's two square root A's. So group those together, that's A. And then I have B, so it's A times B. So both of those are basically the same, the square root of AB and the square root of A times the square root of B. So let's say we want to do something with a -2 that sort of separates out a square root of -1, right?
So would that be. Hold on, let me figure this out. Can't be, right? Or is it just. No, at that point it would be. If that's the case. Give me a second.
So think about what I
Is
just
that
said,
it?
the square root AB thing, or let's say it's like square root of 8, for example. Do you know how to rephrase the square root of 8?
Two
Sort of
times
simplify
4.
it into the, sorry?
Square root of 2 times square root of 4.
Yes, the square root of 2 times the square root of 4. Okay, then what?
Then it would be the square root of 2 times 4.
Yeah, that's the square root of 8, but you've sort of gone around in a circle. So that wasn't necessarily what we wanted to do. The reason why you separated out the square root 4 is why.
Oh,
Because you
so
know square root 4.
2.
That's 2. So I have square root 2 times 2. So that's 2 times the square root of 2. And that is
Yes.
the same reason why we may want to separate out the square root of -1, because we can say that that's I, and then the rest of it will just be some kind of square root that is not as strange, right? Because we took out the negative.
So would that be like? Oh, I see. I see. I see. I see. So it would be I. What? So it would be like I.
Okay, I square root 2. Okay, but let's go even slower. How did we get that? So you wanted to separate out the -1. So
Yes.
so -2 is some number times -1, right?
Yeah.
Which number?
2.
2. Okay. -2 is 2 times -1. Okay. So if we're taking the square root of -2, that's the square root of 2 times -1, which is the square root of 2 times the square root of -1.
Yeah. So the -1. Once we separate out the -1, everything else becomes reasonable.
So the square root of -1 is I. So that's I. And that's the square root of 2. So now I have a certain amount of i's, square root 2, 1.4, whatever
Yes.
this number is, right? Okay. So that's the number of i's that I have. So yes, I can be used in phrasing or rephrasing some kind of square root of a negative. So like square root of -4, for example.
So times 2. Right?
Right. Right. Often we're just talking about like sort of the positive square root, but yes, definitely this is definitely correct. Yeah.
Yeah.
So
So
let's
okay,
just
the
let's just
reason
do
I
this
was
a little
telling
bit
you
slower
like this
once
is like
again.
this is the extent of algebra I learned, and then when people talk about calculus and all that stuff, I have no freaking clue what the.
Okay. Wait. So the -4 is 4 times -1.
Yes.
So the square root of -4 is the square root of 4 times -1, which is the square root of 4 times
Mm-hmm.
the square root of -1.
Yes.
You know the square root of 4, it's 2, and the square root of -1 is something that we call I. And really it's plus or minus 2. So
Yes.
positive 2 times I or negative 2 times I. Either of those could be the square root of -4. Correct. Mhm.
Yep. I
And
got it.
actually, the square root of -1 could actually be plus or minus I.
Why?
Okay, let's try it. I squared is what?
-1.
-1. Okay. But negative I squared.
1? We're still. Oh no, that would be just +1, right? What do you do?
That's negative I
I'm
times
so confused.
negative I,
That
right?
makes yes.
Okay. That's two negatives in a multiplication, so they cancel out. That's I times I.
So -1.
That's -1.
So how can it be plus minus I then? if they're both negative.
Do you know the square root of 4?
Plus minus 2.
Plus or minus 2. This is because 2 squared is 4.
Yeah.
But negative 2 squared
It's also 4.
is also 4. Now, here's something about the square root function. So here's y equals x squared. It looks like this. It is what we call a function, and it passes a certain type of test. People call it the line test informally. It's that each x only has one y associated with it.
Mm-hmm.
So if x is 2, y is 4, right?
Yes.
But if x is 4, if y is 4, what can x be?
Only 2.
If y is 4, what might x be?
Oh, plus minus 2. I see.
Positive or negative 2.
Yes.
Right? And this is why y equals square root of x, which, by the way, this is what happens when you reflect it across the y equals x axis, as we were talking about before. Okay?
Yes.
Okay? This is not a function, technically speaking, because when x is 4, what is y supposed to be?
If x is 4. Oh, by the way, some guy was there. Genius. Saying, why aren't you answering the phone? You should probably go pick me up from the train station now.
Okay, that's not something that we want to talk about right now.
The chat
Wait,
saying.
now? What do you mean now? Not now, later. See, I don't know. Let's see. How do I actually view is that the only person who's watching?
Yes.
Is somebody who wants me to pick this?
Look, we're gonna get more people anyway. So at some point, we
Are
should
we?
play. At some
Maybe
point, we
next
should
time.
play cool math games on here too. There's a site like that.
Sure, I can be a cool math gamer.
And
All right, so we were talking about square roots and powers and I and yeah.
yes,
We can sort of wrap this up by going back up here and taking a look. I to the 1 power. Do you know I to the 1 power?
what do you mean?
If I have one I and that's all I have, how much is that?
It's just like square root of -1.
Which is I. So
Yes.
it's I. In the same way that when I have a 7 and I have 7 to the
Is
1
I
power,
to the 0 1?
that's 7. But I to the 0, okay, good question.
That's
I
1.
to the 0, what should I to the 0 be?
1.
1. In general, any number like 6 to the 0, what should that be?
1.
1. Now, one way of explaining powers is that this is the number of sixes that I have, and if I have 0 sixes, that sounds like, well, what is that? That's no sixes. Is that 0? Is that 1? Like, that's nothing. Is that not even a number or quantity? A different way of looking at powers is that they are a sort of an operator, meaning 6 squared, for example, is something that I can multiply by, right?
I see.
And multiplying by 6 squared should be the same as multiplying by 6 and then multiplying by 6 again. And multiplying by 6 to the 0 should be the same as not multiplying by 6 at all. And when I don't multiply by 6, then I didn't do anything.
Yeah. Okay, I got that.
So that should be like multiplying by 1.
All right. Yeah.
So
So
we can definitely talk about that a little more and give more examples and think a little bit more about that. But that same logic applies to using powers with I. I'm multiplying by I once, that means I'm multiplying by I. If I'm multiplying by I twice, it means I'm multiplying by -1, and so on. So if I'm multiplying by I no times, so not at all, then I'm not multiplying by I and I have the same number. So
and you
it's
can
like
get 1.
multiplying by
Okay.
1.
Which is a rational. Which is not an imaginary number. How?
Yes, which is okay. We can say that the numbers that have I in them, or specifically the component of the complex numbers, that's the I component, is the imaginary part. So like this bi part, right, is the imaginary part,
Mhm.
and this is the real part. And together they make up a complex number. The
Which
complex
is not imaginary.
is in the two dimensions. It could be on the x-axis when b is 0, right? A plus bi. If b is 0, then there's no imaginary component, right?
Yes.
Yeah. Anyway, complex means composed of multiple things, right? I guess technically speaking, right?
Yep, that makes
Complex,
sense.
complicated, composed of different things, whatever. Anyway, so look at this. I to the 0 is 1. I to the 1 is I. I squared is -1. I to the third is negative I, or -1I. And I to the fourth is what?
I to the fourth is just 1.
Just 1. And I to the fifth,
-1. No. I to the fifth would be like 1 with hold on. I'll write it down. That or one
I don't
I.
know what that says.
Or just
Is
just
that 1 times square root of -1?
or just I.
So I to the 0 is 1, I to the 1 is I squared is -1, I to the third is negative I, and I to the fourth is 1.
And I to the fifth is I.
This is because it's I times I times I times I times I. And this is I to the fourth, which is 1. So it's just I.
Solid Washington says I to the power of 0 is 1 genius. It's I.
What's I?
The chat say it says like the I to the power of fifth is I.
How do I look at what the chat says? Oh, I see. 10 minutes. Oh no. Okay. Well, maybe I should actually go. Well, let me just finish this thought. Okay. Yeah. Okay. Let's look at where these things are. So if we graph these numbers in an a plus bi way, right, where every point is the point a comma b, right?
Mm-hmm.
Where would we find 1? Right here.
Yes.
Where would we find I?
That's nowhere.
No. If a plus bi equals I, then what is a and what is b?
They're normal numbers like the two-dimensional.
If a plus bi is I, then what is a and what is b? Is a 7?
No.
Is a 14,000?
No. It can only be
What is
one.
a? If a is 1, okay, and b could be which number?
Hmm.
Should b be 3? So like 1 plus
No,
3i?
no. It can't be three.
How many i's do we have if we have I?
One.
1. Okay, so b is 1. And a, as you said, is which number?
One.
Okay, so that's 1 plus 1i. Is that I?
No.
Okay.
So A has to be 0.
Okay, so a is 0. So 0 plus 1i is I. Okay,
Yes.
so 0 and 1. So a is 0 and b is 1. So the point is 0, 1. Right?
Uh-huh.
Okay, now what about, so this is I to the 0. This is I to the 1. Where is I squared?
Oh, it's the opposite of I1. It's
Okay,
negative
what is I
1.
squared?
Negative 1.
Okay, and what is the point? Describe the point that's -1.
It's right here somewhere.
So a plus bi is -1. So a is what?
A is 0. B is I.
Whoa, okay, no, no. A and b are supposed to be real numbers. Both a and b are real numbers because they're a distance that we're going on the x-axis or the y-axis. So they don't have I in them.
Uh, uh, the B is square root of 1?
If we have -1, if I squared is -1, so we have -1. How many i's do we have?
1.
Must we have any i's if we have -1?
No?
No. So how many i's might we have?
0?
Okay, if we have 0 i's, that b is 0.
I see.
What is a?
Negative 1.
Okay, so -1 plus 0 I could be -1.
Yes.
Okay, where is that on this two-dimensional space?
Right here, negative 1?
So that's -1 comma 0, correct?
Yes.
Where -1 is the x value and 0 is the y value. And the x
Oh,
value,
so hold on. So it's here? You're kidding
okay,
me.
the x value is how many steps to the right I take. But if it's a negative value, then that means I go to the left. So correct, it's right here. And 0 I, so I don't go up and I don't go down. Right. Okay, next, I to the third.
So it's negative I.
Yes.
Which would be. No, that's what's puzzling me. Hold on. A plus bi equals negative I.
Right. So what could
So
A and B be?
actually, sorry, my brain works in weird ways, but I think this is like
No, that's okay. This takes some time usually. So 0 plus -1I is -I. And
yes.
-I is I to the third.
So it would be here again.
What do you mean here again?
Negative I would be here, or right here.
Where would -I be?
Here.
Okay, this is because if we look at A plus BI and we have 0 plus -1I, that means we do not go to the left or the right because the x value is 0. But the y value is -1, so we go down.
I see.
Okay, so that's I to the third right here.
Yep.
Okay, and I to the fourth.
It's 1.
Okay,
So for it to be equal 1, B has to be 0. And this has to be 1. So I to the fourth would be Would it be intersecting with the I to the 0?
I to the fourth is 1. I to the 0 is also 1.
So they're intersecting.
So what we have discovered is that it kind of just goes like this, right?
A circle.
Okay. For homework, we may want to find the square root of I, or I to the 1/2 power. So it would stand to reason that it could be like halfway somehow between I to the 0 and I to the 1.
I see.
Okay. Maybe we'll talk about that next time.
All right. Thank you everyone for watching. This
Okay.
has been Zeke and
Thank you very
Lectures.
much. We've had way too many messages in the chat, and we've really been overwhelmed. So we've not been able to address any of your concerns. So maybe next time.
All right. Go and address the
Okay.
chatter's concerns.
Thank you.
Bye-bye.
Enjoy your weekend. Do you want this? We can make a PDF out of this as well, maybe.
Sure, we can.
That could be useful. Maybe I could share that. Maybe I could share that in like the description.
Yes.
Okay.
All right.